Okay, this morning's session is going to be for motherboards. Hopefully, we all got a good rest this weekend because this is going to be a pretty hectic week. We got a lot to cover. As I stated, the whole week as we progress is going to be more in reference to the technical. This afternoon, as you saw in your calendar, we have a session for a BSM. And for this, our main objectives is to be able to explain the key role of a motherboard, describe and identify the components. We want to be able to identify when it's required any maintenance checks within a motherboard, name the steps installing an actual motherboard and using the BIOS, identifying the common pitfalls in installing motherboards. As we stated, there's little holes and stuff like that that are marked. Sometimes people also break it because they don't try to align the hole, so we'll be seeing those things. Describe common problems that come up, including overheating, and describe how to solve these common problems. So, Jordan, if you can help us with the first one here. What is a motherboard?
Motherboard, also known as MOBO, provides the foundation for the PC since it connects directly or indirectly to all pieces of hardware.
Thank you. Basically, as we've seen before, and we know it's a multi-layered circuit board. We said there's pathways on it. We've seen pictures of it where everything, as he stated, connects. MOBO is one of the new terms that they're using out there. We didn't use it back in the day. At least I never heard it be called MOBO until I started teaching this class. Before that, obviously, it's either you ride the bus or just a plain old motherboard, but I'm pretty sure with the new Ys or Zs, whatever generation it is, somebody came up with the word MOBO. Some layers obviously carry actual data, while other layers just distribute power from the power supply itself. The interface to configure the motherboard is called the BIOS, which is the actual booting chip. If we recall from last week, is that little chip with the little legs that looks like I would say almost like a weird ant or some bug. That one is the one that usually uses the post to check all your components, and that's where usually it uses a CMOS to store the information of all the components that are installed on your computer itself. Alexa, you could help us out here with motherboards, forms, and factors.
Motherboard form factors. All motherboards come in a rectangular or square shape that vary in overall size and in the layout of built-in components. The form factor applies to the case, motherboard, and power supply and defines how the air moves around the case. The most popular motherboard form factors are ATX, Micro ATX, and ITX.
Thank you. So basically, the majority of the people will recognize an ATX board. That's what a lot of the computers have since after the new layouts came out. And basically, we'll look at the different forms. The micro is a little bit smaller, and then we have the ITX and the nano, the Pico, the mobile. All those are motherboards. As we know, all components now, even your actual phone technically is a computer. So they had to create different motherboards to be able to facilitate the process. And obviously, each one has less and less components. When we see here the first one, which is the ATX, which is a standard ATX, it has much more space for memory, as you can see here. It also has many more slots for, anybody can tell me here, Pablo, you can tell me which, by taking a wild guess from what we learned, what do you think these slots are right here? Or anybody, instead of Pablo, want to just chime in?
It's a PCI 16 lane, and I can see there's about 5 of those.
Yes, correct. should be able to start recognizing these because from above we should be able to recognize that it only has one little doohickey. He's a cream color. He's not brown or the other color that we're expecting to be the faster slots. So this one here also is cream, the old colored cream instead of yellow. This one seems to be more of a board. This is still the same exact slots. But if you notice, this one has 5 and this one has 2. And this one only has 1. The more smaller it gets, depending on the actual device, some of these things are the little pay kiosk devices sometimes are very small. The bank tellers and stuff like that, where your ATM is, may have a smaller motherboard compared to the one that you have. And also all those microcomputers, you'll see that there's a small little computer that looks like just mostly for terminals. Again, that would be most likely a micro ATX or a mini ITX. So types of case is always going to be determining what type of motherboard you're going to put in. Definitely. If it's a small case, you can't put an ATX. There's no way you're going to be able to fit it. What's wonderful, sometimes these big cases, though, allow you to, that you'll see that they'll have the holes where the micro ATX is and the standard ATX. So it actually aligns so that you could actually put it into that case. Although the motherboard is smaller, but the holes align to the other one so that when you put it in, it's going to be against the wall and it'll be in those screws that are closest to the actual wall where the ports are supposed to be coming out. That's some, not all, obviously. Each case and power supply will be different if you're creating your own, especially the gamers out there. They know that they should be actually checking how much watts they're going to be using, because if they don't know how much they're utilizing and they just buy something with a power supply that's small in actually giving so many watts, then you're basically not going to be able to power up that video card and or certain sections of your computer. Again, the type of slots, as we said, and or the CPU speed, all that is determined by the motherboard and or case that you're going to be putting it into. Any questions on this slot here? Anybody know what plug and play is? Or we used to call plug and pray. Now it's much easier.
Plug it and it should work, hopefully.
And correct, am I plugging it to the wall?
No, I'm pretty sure it's referring to like just plugging your expensive devices and to see if it just works. Like I put in my graphic card, it should work, and the operating system should auto detect it all.
Correct. Basically, the BIOS, when coming up, should be able to detect if the motherboard is supposed to receive this type of technology. It will recognize the CPU, it will recognize the memory, it will recognize, like as he stated, all these devices and allow them to connect, and then the operating system will be given the information so that it could then hopefully have what they call an HCL, a hardware compatibility list, which we don't need to know until in 1002, but that is passed on to the OS so that they can be able to add the drivers without you having to put the drivers usually nowadays. Prior to this, we had to actually manually tell what the computer to expect. So if I had an SVGA card or if I had a 50 megabyte hard drive, yes, I said 50 megabyte hard drive, I had to tell it how many heads and sectors and all this stuff that it had so that it could recognize the hard drive. Not just say that it was a 50 megabyte hard drive, I had to tell exactly how many heads, sectors, and I forgot what was the other thing, but there was 3 numbers that you had to punch into the BIOS. The same thing, if I had a communications port on my computer or a parallel port, I had to tell it exactly what it was and what IRQ and all the settings. If I did anything incorrectly, the computer would crash completely, because if I set 2 components with the exact same IRQ, it would crash. All of this now is done automatically, not manually by anyone. It's a wonderful thing, which is IRQ is interrupt request. Basically, just like in the token ring where somebody's talking in a network or electricity, each person is able to talk at a certain point of the clock. You would get a ticketing system that says you're number 7, so you get to talk when number 7 is supposed to talk. That would be your mouse per se. All this now with plug and play has gone away. Hey, look, I'm a little rapper, and I didn't know it. Anyways, in here is the different types of expansion slots. You have your CPU, you have your RAM modules. We should be able to recognize a landing grid or a ones with the socket. And that right here, in other words, when I see this square, what should I know? Automatically, any square like that going in that size, what is that? It says here CPU. So from the chip to the actual socket, we need to be able to recognize that. The same thing here. As you'll notice, here goes the RAM. How do I know? It has the little things that they call the ears next to it. So it's black or sometimes blue and green, right? Because if it has different channels, if it's single or double inline, it'll tell you by the colors that it has. In this case, they're all, looks to be only one channel. So we need to make sure that they're all the same exact type of modules, right? If not, it's not going to recognize it. E, if you could help us out here, what's your name?
Yes.
Okay. Will you help us out here with this slide? Thank you.
Yeah. PCI, peripheral component interconnect. The first PCI has had a 32-bit data path supplied 5 volts of power to an adapter port and operated at 33 megahertz. PCI version
Don't worry, up to there. Thank you.
2.x introduced a 64-bit 3.3 volt PCI slot, doubling data throughout the bus. Because a card can be damaged if installed in the wrong voltage slot, a notch in a PCI slot distinguishes between a 5-volt slot and a 3.3 volt slot. Conventional PCI is no longer evolving and ending up with 4 types of slot. It can achieve bandwidth of 133, 266, or 532 MP per second.
Thank you very much. Notice they gave us the bandwidth. And this is the problem that existed in the old computers, is that everybody started creating these chips that were so fast and flying fast, but can anybody, from what they can see there, what's the problem with this PCI slot and the fastest it can go?
If it's referring to the old one, I know that they had a shared bus, a parallel, and with the system crystals, if they all not sync correctly, like for example 100 megahertz or 200 megahertz, it gets out of sync and it can mess up the communication.
Also, the speed here, if you'll notice, is 133, 266, and 532 megabytes per second, while most of these processors nowadays run at a gigahertz. That's why they invented, which we're going to see soon, the North and the South Bridge, is because the PCI, the USB, your mouse, keyboard, all these devices run much slower than what the processor runs. So as I stated before, you're only as good as your slowest link. So if everybody, or if your fastest link is running at 532, guess what? You are running at 532, not actually running at that gigahertz because of the fact that that is your slowest link. Now here is a picture of the actual PCI port. You'll notice the variants on purpose. They make sure, so if you saw the cream colored slot and you tried to put this in a 5 when it only supposed to have 3, if you'll notice, the little notch won't let you. So the card that's going to go in here, the notch is completely on the other side. It's the same thing with the 64-bit. The notch is in a separate slot because of the fact that they don't want you as a technician to go and install something by mistake. They're all going to have that cream color, but the variance is that obviously the slot has the different notches, and you then have to be able to then determine, okay, if it's like this, then it's 5, while this one here is 3. Any questions or doubts? So when you purchase it, you need to know what you're purchasing, obviously. Usually your manual of your motherboard will tell you exactly what type. If not, you could look it up on the internet. of the manufacturer. Expansion slots here is the PCI-X. That's the extended one, offers higher speed compared to the PCI. Same thing with the mini PCI. This one's for the laptop. Smaller versions of PCI used in laptops. There's nothing different except for the lower power consumption. AGP, that's the accelerated graphic ports. So that hopefully resonates and everybody remembers what it is. It's a new video graphic port. It's the one that's faster. You'll notice here though, also it's completely different. If look how it is. This white one here is here, and it's even in a different alignment so that there's no guessing when you're coming in. Look at this gap, this humongous gap that there is. Usually these things have a processor on with them, and they're connecting directly to the North Bridge. They're much faster than no one talks to the CPU, if you notice. So far, I haven't told you anybody's talking to the CPU. Everybody's either talking to the North or the South Bridge. The North Bridge, you'll find out, is the one that actually talks to the CPU and the memory. They're the ones that are in line with each other. Any questions or doubts on the AGP versus the PCI so far? The PCIe is the next level of high speed. It's an alternative, obviously, to PCI. A lot of the gamers are using this. I'm pretty sure they're very familiar with this one. This one, I've even seen some PCs that have this and other various processors, and they have the liquid nitrogen. Those computers are beautiful because they actually pretty much just light up and glow with the liquid nitrogen tubes going right through them, through the processor of where the heat sink is, going through there and going through the actual processor of the computer, and a radiator. It has a radiator inside. Yes, I said radiator like a car, so they can kind of cool down again the liquid while it's going in that motion around the computer. Here is all the different versions and different lanes and speeds and throughputs. Obviously, these are things that we should be able to recognize. And one quick way to learn is that there's up to 4, right? So if we did our little math that we should know, you'll notice that these numbers start coming out again. Those binary numbers that I was telling you should be learning. It's starting at 8 gigabytes. That means my version 1 is at 8. The next one doubles. It goes to 16. So my version 2 go to 16. Again, 32, then 64. So you should hopefully, at least if you remember that PCI Express 1 has 8 gigabytes of throughput, you should know everybody else should be doubled up upon that. It's the easiest way I can remember, so I don't have to try to memorize so much information for myself. I try to put easy ways to remember it for myself. And then after, obviously, of use and use over, you'll say, okay, the 4th one, that's obviously 64. But then that's obviously of years of going over and over through it. By then, they'll probably change it on you anyways. PCIe. So if you notice, there is a 16 and there's a little small one and a big one. There's also this one here, which is 4. There's a whole bunch of different ones compared to the actual PCI. Once again, if you'll notice, this one is a different manufacturer. This guy is actually using different shades of blue. And from these different shades of blue, I know that this is the lightest one. And since it is the lightest one, I should consider that's cream. Just like in any other electricity, when you're supposed to know which one's red and black or yellow or whatever, white, you should know that the lightest one should be the lightest one, and the darkest one should be black or whatever it is that you're looking for. Any questions or doubts on the PCIe slots and what they look like compared to the PCI? Chipsets. Justin, if you could help us out here with this one.
Of course. Chipsets. Every motherboard has a chipset, which is one or more integrated circuit chips that support CPUs interfacing to all other devices. The chipset must be compatible with the processor it serves. The most common sets of chips are Northbridge, connecting the high-speed interface, CPU, RAM, video. It is located closest to the CPU. The south bridge connects the lower speed devices, hard drive, USB, expansion devices, BIOS. It handles all input-output functions. They are embedded in the motherboard with its own heat sinks. Two major chipset manufacturers are Intel and AMD.
Thank you. As we reviewed before, Intel and AMD are the top ones out there that are the manufacturers for these. AMD has the capability of overclocking, unless if something's changed from what I learned. You could actually overclock it and push it faster and have the motherboard recognize a much faster speed. And as we stated before, the North Bridge is the one where everything that is supposed to be flying, or at least the fastest, is going there. That's the thing that you need to memorize, unfortunately. You need to be able to recognize that the South Bridge is the ones with the lower speed. So your network card will probably be there, your inputs, your outputs will be there, your hard drive, your USBs, stuff like that would be there. While the North Bridge is who's going to be talking to the the CPU or the RAM, or if it's AGP and PCIe, it would be video. That's all close to perspective on the motherboard to the CPU. So you'll see the CPU here, and even if you see a diagram that they're going to show you, the closest, no matter if it's going sideways, this way, which way they do it, the closest chipset to there would be the North Bridge. Then comes the South Bridge. That's the easiest way to know, because the longer it takes to get there, also, so you have latency to the South Bridge because of distance. And since they're going slow, it doesn't matter. You want to keep the North Bridge close because they're flying, and then also the latency is much lesser. Here's the drawing, as I stated, where you could see an actual chipset. You have the North Bridge and the South Bridge. Here's your CPU. You see how your CPU is back here. And then, like I said, no matter what it is, the closest guy to him, it's got to be the North Bridge. There'll be another CPU, basically. That's what he is. It's just a smaller piece CPU. Then you'll notice that even the South Bridge himself, since he has some new things, which is the USB 3, and some of these things are much faster than your serial port, your floppy disk, your keyboard, which is much slower. They have created a thing which is the Super IO. He's the actual guy that's going to actually help the South Bridge. So now the South Bridge was just going too slow because of these devices. So they added another chipset. That's all depending on the motherboard. Again, it's not mandated, but you'll notice sometimes there will be an extra chip, which you'll notice it looks like a CPU exactly. It's going to be squared shaped, and it's usually called the Super IO, Super Input Output. That's where your serial port, your parallel port, your floppy disk, keyboard, anything that really, really is slow compared to your SATA drives, your USB, or any of the other things that's a little bit faster, that's going to be connected to the South Bridge. Any questions in the diagram itself and or the different components here? Remember, this is just a diagram to facilitate the bus, which would be all the little wires or pathways that are in the back. So don't expect it to physically be this way, just a representation. So if we flip it over, usually there's a lot of copper and or gold that is soldered in the back, creating this bus connection to all these different components. Questions or doubts before we go into the next one? Here we are. So diving a little bit into here a little further, we have the new technologies allowed obviously the CPU to absorb the North Bridge to increase communication speed, as I said, for the RAM and video. The South Bridge is obviously visible on the motherboard, and its name changed to the PCH. That's depending on some of the newer chipset and stuff like that. But in essence, there's still a North and South Bridge. They're not actually like a manufacturer called North Bridge and a manufacturer called South Bridge per se. It's just what they're called and where they are. clock generator. So each computer has its own clock generator. This is what determines the speed at which the CPU, chipset, and RAMs can run on. Sometimes you'll see, no, always, you will see on some of these chipsets that say clock speed of 5, clock speed of 7 on your memory, which we're going to find out what that means. And that's in reference to they're talking about is this little guy. He's the one that actually is soldered onto the motherboard and creates that little clock that I was saying where everybody can talk. So how fast it can go around this clock is how fast it could actually go with a CPU, depending on the actual clock cycles and or megahertz of frequency it can go. So 1 million cycles per second this little doohickey can go. Just to get a little perspective of how fast he goes. Questions? So Lázaro, can you help us out here with this slide?
Yes, sir. Motherboard ROM BIOS system serves 3 purposes. System BIOS, data and instruction code that enables the CPU to communicate and manage devices such as keyboards, mouse, hard drives, memory, and monitor. It is stored in a flash ROM. ROM chips that can be overwritten. Setup BIOS perform hardware installation during the booting process. Post. BIOS setup. Change motherboard settings. It is stored in a CMOS ROM, which is built into the soft bridge. Includes data, time, port configuration, and boot order. Requiring a battery, CMOS battery, to maintain all settings.
Thank you. So basically, I think we mentioned this, the BIOS, or what they call the basic input-output system. This is usually the system that's into all computers. Now there is the UEFI one. There's a newer one that's being replaced. It stores, as I said, the information, what they call the CMOS RAM. So you have your flash ROM or your BIOS that supposedly you're not supposed to be able to write onto it. Some of the new ones allow you to update them. But the RAM or the CMOS RAM is where it saves all the information. If you have a boot up password, it saves it there onto that actual RAM, and it has the actual information stored, which includes the RAM, includes your CPU, your hard drive, whatever settings you have. If I take out that battery, that would probably be one way that I could actually reset everything. So it's going to forget what time it is. It's going to forget what your password was. So now I just hacked your computer. You thought you actually put something to stop me. And all I had to do was just basically unplug your computer, take out that little battery, and I'm in. So yes, although these tools are out there, but that's what they call security through obscurity. We're going to learn that in later chapters. Although it has that information, the main purpose of this CMOS battery, which you'll see usually in clocks, that little round circle battery that you could find in Walmart or anywhere, actually, that's the one that's storing all your information. Let's go up to there, guys. I'm going to pause the video, and we'll come back in about 15 minutes. Let's take our morning break. Okay. You guys can see my screen or in the Nearpod, if anything following along in your Nearpod. Please remember, if Nearpod is giving you problems, to open up maybe Word or some other type of note-taking device, be a actual notepad or a other software in here inside your computer. So any questions? I guess we can go over this real quick before we proceed. Any questions in reference to the 3 main purposes for the motherboard ROM BIOS? Questions, doubts? Feel free.
I have a question.
Mhm.
Are all these things happening at the same time, or does it go in a order, like the BIOS?
Well, the BIOS is the one that starts everything. So when you power up, the first thing that starts to work is the BIOS. Usually that you'll hear it going beep, a little noise indicating that the host is happening. So in other words, it's checking to make sure that everything is functioning correctly, and obviously assigning IRQs or whatever it needs to do in the background, as we stated a minute ago for the plug and pray or plug and play part of it. And so it's assigning everybody their own time to talk during that cycle per se. All of that happens as soon as he finishes, he passes it then to basically at that point to the hard drive to start booting, or whatever's in the BIOS as the main boot order. Because we'll learn that in a minute. I could actually have my USB as my main one to boot up, and it'll boot up with my USB instead of my hard drive or a CD. So it's all up to what you determine your boot order is and what your configuration is in the BIOS, and then from there it'll attempt to boot. Did that help answer the question, or
Yeah, thank you.
Good. So here's your little CMOS battery. So like I said, there's the actual BIOS is stored on another chip, and then this battery is what powers the CMOS. As we learn, RAM will delete everything as soon as you turn off your computer. All of the RAM, random access memory, gets deleted. So this little thing makes sure that the actual CMOS RAM and the information that's stored there, including your time, is obviously saved and consistent. The moment that you see that you start losing your time and or configuration every time you turn on and off your computer, you can bet that you can just gotta go and buy this little thing. Like I said, you can buy it pretty much anywhere. You'll see these little circle batteries everywhere. You push back on this little device here with the little small screwdriver, and with ease, you should be able to kind of pop it out. And then just the same thing, you kind of push it in and lock it into its place by itself. It has a spring load there. Question on the firmware chip here and the battery location. Okay. So what other settings and utilities? Well, you're able to now flash some BIOS. You're capable of doing that. And as we said, the BIOS components contains the RAM, your drive, your CPU. It has its own built-in diagnostics to be able to see if there's something wrong. So you could actually stop it from doing what they consider a fast post or a fast just check, and actually force it within the BIOS setting. You can actually make it do a thorough check, thorough diagnostics of everything. And if here you could obviously see that you can configure your boot sequence, as I stated, depending what drive you want or what device you want to start up. You could disable or enable your devices. You could set your date and time, your clock speed, your bus speed, your biosecurity password, as we stated. It also has monitoring capabilities of seeing the temperature, your fan speeds, and all that is inside a menu where you can see all of this information. Any questions on the settings and or utilities within the BIOS? Here is a view of a BIOS. You'll notice that the BIOS is the old screens. These are the old ones that are out there. The new UEFI, you'll be able to notice because your mouse works. Right away, you'll notice that your mouse works in there. That is a huge hint that you are no longer dealing with a BIOS, which is the old computers, versus the new computers, which is a UEFI to be able to boot up the computer. It has much more stuff like the TPM for the encryption and for more sophisticated, obviously, chipsets. But this is the old view. You'll see that with the keyboard, you can go with your arrow keys and navigate left or right. On the top here, you have your main, advanced. Like I said, you can actually tweak it. So if I had an AMD processor and I wanted to push it faster, most likely I go in here and start tweaking stuff. Here's a menu for boot and a menu for security. All of them pretty much feel the same and have the same view and more or less. There may be a slight difference in color, but what it is, the left and right, up and down, that doesn't change. You still have capability of having F10 on your keyboard itself. So the function key, you hit that and it will save and exit from this screen and basically boot. Any questions in the actual menu or how to navigate through the menu? So here's your UEFI. That's the Unified Extensible Firmware Interface. This is the one that's more robust. As I said, it does the exact same functions and more. It pretty much replaces the BIOS in all of the modern systems, basically. Like a BIOS is responsible of doing basically the same thing. It supports systems enabling boot devices larger than 2.2 terabytes. This is one of the major issues we had with the old ones. They couldn't recognize hard drives that were over 2.2 terabytes. Obviously, that wasn't a necessity prior to this, but nowadays that is like a must. 2 terabytes is almost nothing nowadays. Supports 32 bits and 64-bit operating systems. We're going to learn about that in the later half, but that is critical. Without the newer versions of the computers, you won't be able to do, in a lot of these old motherboards, a 64-bit operating system. It supports also the graphical interface, as I stated. So no longer do you have that boring little DOS menu where you needed to move around with your keyboard. You could actually use your mouse to navigate, and it has much more, instead of being 256 color, it has a much more graphical user interface view, more graphics and or technology, including the mouse, to be able to navigate and do everything. No longer do you just need the keyboard. Here goes the view. As you can see, it's much more fancier. So I could most likely come over here and change the boot order with ease. Again, you can still go and navigate with your keyboard around, but most of this is a GUI, what they call a graphic user interface for the user to be able to see with ease anywhere you want to be. And the same thing, you can exit, go into advanced mode and different views from this menu. The same exact things. The only thing that this has much more features, and as you can tell here, I can actually change for it to be quiet, energy saving, and or performance. That'll push how fast the fan will go, or willing to actually make, if you're in a library setting or some location where you don't want to hear that fan blowing, because if a lot of these computers start blowing the fan, then obviously it's going to be bothersome. Another reason you might actually change it to being towards performance is if it's servers and stuff like that, you want to make sure it's keeping cool and it is actually consuming that fan speed and or wattage as necessary. Any questions or doubts? The difference between a UEFI and a BIOS? They're the same. The variance is the UEFI is the newer one, which allows you also to work with the TPM. Has an extra chip for encryption. Here we are with connectors, and more connectors. This, unfortunately, is time consuming. We need to be able to recognize these connectors on a fly by our own. We need to recognize that these over here are all Molex types. So all the ones here are usually found inside the computer, and they'll have strange little teeth. While these guys here are more rectangle, those are the front panel ones. Those don't have these little strange grooves or teeth or shapes. These usually are more rectangle and are in the front panel and will go onto the motherboard. We should always take note of the colors because everybody has their own little colors. The speakers usually are these colors, but per se, take a picture before you take it off. So like that, with ease, you'll know which way it goes. Because if not, you might put positive to negative and negative to positive, and then you're gonna have to be playing that game of flip-flopping. Because like I said, these are rectangle, there's no grooves, there's no way of figuring out if you're doing it incorrectly when it comes to the front panel. These over here, the fan connectors and or power supplies for sometimes for the old drives, your floppy drives, or your CD-ROMs and or IDEs would have this power Molex connectors. Over here on the top, this is the big doohickey that comes straight from the actual power supply to the motherboard. So this guy, if you notice, on purpose, since it is a perfect rectangle, you'll notice that there's a square, a triangle shape, a square. If I flip-flop it, you'll notice then the square is not here. It's a triangle. So if I, by mistake, I try to put this incorrectly, it will not allow me because each specific hole has its own little shape that must align to the connector. They do this a lot. So the most part you need to do is recognize where the notch is and or just flip it. Here is an IDE connector. You'll notice that it has different colors, the one right above compared to the one below. Most likely one's what they spot 0 and one spot 1. Spot 0 would actually be the main one. As we know, computers use 0, so 0 is a number for it, or a spot always, even in programming. So next here, we have our USB slots. So sometimes there's actually little cables that come straight from here, going straight towards the panel, that metal panel that we have in the back. And sometimes it's just directly to the motherboard. We have our SATA ports here, which basically could be either in yellowish color or this black color here. Any questions, doubts? We have other input output. So when I say I/O, or whenever you see I/O, that's exactly what it means. Input output interfaces. You have your USB 2.0s, your display ports. That is a video type port. In other words, you have your new HDMI high definition. You have your DVI ports, which we seen before, right? You have your LAN, your USB 3. If you notice, your 2s are black and your 3s are blue, so that there's no confusion from the fly. When you look at the back, you'll know which port is USB 3 and which one's USB 2 by the color. Over here, you have the various different inputs and outputs. You have your audio line in, you have your out, you have your microphone, you have your optical here, which is the a fiber optic cable. You guys have probably seen it, a little red light that comes sometimes in the back of some of your fancy power computers. Some of them have this. I know the Xbox and or the PlayStation, you'll see this little fiber optic connector in the back of it, so you can be able to have high definition audio. Any questions, doubts? Each one has its color. If you notice, black, yellow, blue, green, there's no doubts. If you learn the colors, you'll be able to know which port is which. Next view here. Let me see who I can pick on. Alexa, telling me in quadrants real quick, hopefully without reading, where do you think the north bridge is, Alexa? Here's the CPU. Which one should be my north bridge?
Which one? What? Sorry.
Your north bridge, the chipset that's the north bridge. That's here's my CPU. So which one is my north bridge? What does it look like? It should be very close to it, right?
Yes. It's
So what's the closest chipset or square that's big? It's usually the biggest one closest to the CPU.
in the middle.
Yes, correct. So this middle guy here with its own heat sink, and if you notice, it's kind of soldered on. There's no way of taking it off. So that's another big indicator that that is my fridge. He's got that big, humongous heat sink. While this here, we know that we're going to put our CPU, it's going to have a heat sink and a fan, right? And over here, we have all of our connectors. That's usually where our peripherals, but that's going to face, as we always know when we put it in, towards a plate on the back of the computer. Any questions or doubts? Teresa, can you tell me where is the PCI slots connected to? Is it connected to the north bridge or is it connected to the south bridge? PCI slot. This guy.
It's connected by the south bridge.
Thank you. Daniel, can you tell me the AGP slot? Is it connected to the south bridge or the north bridge?
It's connected to the south.
Why would it be connected to the south? Let me rephrase that question. What is an AGP slot? Anyone
Um,
about Daniel?
Graphic accelerator. Sorry,
Yeah.
accelerator graphic port.
Yeah. So it's an accelerated graphics port. So it sounds like graphics and it's fast. So would he go to the slow guy that's South Bridge, or would he go to the fast guy who's the North Bridge?
the north.
Oh, okay, thank you, Daniel. Yeah, so that's things that we will help us determine, because here it was a little harder. He's right in between the two of them, and physically it looks like he is connected to this one because he's below him. But if you notice, he's still he's very close to this chip, not
The
close.
north.
We can probably bet our bottom dollar that anything that is above this slot right here, this way, most likely has something to do with the North Bridge. We have our memory here, right? So anything real close to this guy is probably going with the North Bridge. Although these are close to the CPU, can somebody tell me where these peripherals, Justin, can you tell me where all these peripherals are going to get connected to? If it's not the South Bridge, where would it go to? We know it should go to the South Bridge because it's very, very slow. But where should the majority of these, if there was something fancier helping out my South Bridge, what's it called? I'll give you a hint. It's obviously not in this picture. So he'll be a little helper to the South Bridge. We learned about it about a couple of minutes ago. He's called a who?
Oh, it's that one chip that goes on the South
Yes,
Bridge.
correct.
Uh,
And he sounds like Batman or some type of superhero. And he's an input and output. I can just spell it out there. Nobody laugh. I know I gave the answer out. It's somewhere in my sentence. He's a superhero that has to do with input and output. Still, come on.
the Super IO chip.
Yeah, the Super IO. He's the helper. He'll be obviously dealing with all those slow guys, the ones that are really slow to the South Bridge. Thank you for playing along and helping. Any questions or doubts on these view that we have here on this board? Can anybody take a guess? Levi, can you take a guess on what type of motherboard this is? So it's a big one. It's a normal.
Today, Diego.
Oh, no, he's not. I'm so sorry.
Sorry.
I could call Joseph again, but then that would be a bad.
Not in place.
Jordan, if you could help us out, what type of motherboard are we looking at here? Is it a micro, a nano, R2D2? What is it?
Most likely an ATX.
Thank you.
ATX.
Yeah. It has 5 PCI slots. We know it's got to be huge, even though physically we can't see it in our hands, but it does have 5 slots, which we said earlier. That was one of the usual criteria. It has about 5 slots. Now, those 5 slots are not always PCI. They could be AGP and PCIe, but we know that it's going to have a whole bunch of slots available compared to the smaller ones. Thank you. So, thank you, Jordan. Here I am trying to use my mouse to control my iPad. Embarrassing. Pablo, if you could tell me what A is, Pablo, please.
A would be the memory.
Here's A, and he's going to this guy here.
Right here. All right. A PCI slot.
Thank you. Yes, that is correct. Now, what helped you to determine that? What was one of the fast things that kind of helped you? You knew it was some type of...
The color.
Yeah, that the color did help, right? Mohammed, if you can give me the B slot from what we've learned so far, do you think you could determine what B is?
Yeah, it's a PCIe slot. It's a faster one.
Thank you. Yeah, I would take PCIe if you don't know the actual voltage, it's not a major deal. As long as you can actually recognize the card, that when you have it in your hand, you know where it's got to go. I don't think the test is going to be very picky on what voltage it is. It obviously helps you. I don't think that very picky about voltage and knowing the voltage for each one. I would still know it for your own, obviously, good knowledge. It's very useful, but I don't know if they go that in detail of having to be picky about what exactly. I don't remember that ever coming up as a question whenever I've taken the test.
For the sake of knowing, can we know at least exactly which one that is?
Yes, we can go back to the slide if you like. Yeah.
Cool.
So that was a small one, right? So let's go back.
Yes.
Oof, I didn't know it was going back this far.
Oh yeah, it's pretty far. PCIe. Here's a small one. So, the small one, and it must be then. From what I saw, it was just this one right here, right? It had that little slash here. It should be then, from the looks of it, if it's a small one, it's either the 1.5 or the 3. I think it was the 3. From what I saw.
I think it was a PCI 1 by 1 or.
Oh no, this is AGP. Sorry, my fault.
Oh.
Okay, so all we know is this here, PCIe 1. So that's the 1. Let's see if it has it in the next. Nope. So it's called the PCIe 1.
Okay.
This is by 4, because the one we were getting confused was with the AGP. The AGP had different things. Here's a 16. There's a 4. There's the 8. So that's how you should be able to determine. The small one is a PCIe 1. The big one, human one, is 16. And you got the 4 and the 8, which we saw. I believe was the 1. Thank you for the question. Any other questions? These are also, I also put in the classwork, the pages that correspond to the A+ book. So if you guys want to be following along, you should be on pages 1 through 38 on the book itself, if you want to look at the book or if you wanted to review afterwards. And also the homework book, hopefully if you read it, should have reviewed these things. All right, so the next one, let's see here. Who was next in my little app? Thank you, Mohammed. Julie, if you can tell me what is F. F is here, down here in the bottom. It's like yellow, and then there's like an orangey red, depending on your graphic. Julie.
Okay, so that one is not the PCIe thing, right?
No, that's this guy over here, right? The C.
Yeah.
I'm sorry. The video cards will be somewhere over here. So it's over here. It's next to the CPU, and he's got 2 ears. But you might get it confused with the other one, which has ears. But this one also has 2 ears, and it's near the CPU. I'll give you that much of a hint. So what talks to the CPU always? Long, skinny chips. Alexa, can you help Julie? What would be this long, skinny chip that I would be installing? And then look, they have it in 2 colors, so that means there's 2 channels. Anybody want to jump in and help our team?
The name.
I'm sorry?
I like a
I
memory
can't quite remember the name of it.
What
Isn't it REM?
RAM.
I like
It's
the
a
RAM.
RAM.
RAM, correct. We'll be learning in which one is him, which one is him, and all the different type. But all I was looking for is at least recognize that should be memory slots there, your RAM, your random access memory, RAM. Thank you for the help there, Mohammed. Julie, for participating. Justin, can you take a guess here on H for me? So he's got a whole bunch of teeth. He's black, and he's got a little notch here.
Hmm.
Okay, well, anyone can chime in. How's that? We'll play the game this way. Anyone want to help him out? What
Power supply, or maybe the G1 is the power supply.
G
IDE?
power supply? Yeah, but H. We're on H. So somebody said something. I'm sorry. Who else answered earlier?
IDE?
That is correct. That is an IDE port that can be used for hard drives, compact discs, different different peripherals in there. So you could put in there. So any of your drives, your backup drive, anything that will be reading and writing towards the board. If you'll notice though, this board, can somebody tell me what type of board we're looking at, please? Help me out. Seems to be a little bit different than the previous screen that we have. And it has how many?
The mini ATX.
Seems to be a little smaller, right?
Yes.
Or is it?
Micro ATX?
Pro micro.
Let's look at it. How many slots do we have? That was a trick question. How many slots do we have for expansion? So we're going to look over here. How do I know that they're expansion slots? Because they'll line up with these guys here. Here's my USBs, all of my different peripherals that are available. And then these right here that are right below them usually are going to be my what you consider expansion slots, stuff that I can put into. From here all the way up to here are expansion slots. So I have two PCIs, right? We said that PCI, we have an AGP and a PCIe. So technically, it is an ATX board. Do we all agree? It's got 1, 2, 3, 4, 5, 6, 7 expansion slots. It looks smaller, but it's not. It's just the alignment of it. Now you tell me, Diego, but you've gone crazy. There's only one port that I can connect here. That is correct. There's only one IDE port here. You also got another one over here. But if you notice, all of the new drives actually use this new connector. So I have 6 connectors for my drives here. Anybody want to take a wild guess? If it's not IDE, what would be that port?
Lazaro said it. You didn't hear him though.
Okay. I'm sorry? Lázaro?
He said SATA.
That's right. So if we'll notice here, we had our different PCI slots back there. We had our CPU sockets that we were looking at, memory slots. G was our main power. So that's the main power, as Mohammed told us earlier. Our floppy connector and or IDE slot was H. Our fan connector was I. Our IDE was K over here. We also have the front panel connectors was where L was. So L was right here. So here's where my front panel, all those little cables would go. And over here is K and H. Any questions or doubts? This one actually was a smaller than IDE from what they're telling us. This is smaller, right? It was a floppy one. While this one is the bigger one, is K is the IDE one. Slightly bigger than this guy here. Less teeth. Questions or doubts? Now, on the board itself, whenever we have doubts, they also print exactly what the port is, real small, right next to the port usually, so that there's no doubts for the technician when he's using. Especially here, when there's various of them, they'll tell you which one's SATA 0, SATA 1, SATA 2, up to whatever number that there is there. Since there's 6, it's going to start at 0 and most likely end at 5, because 0 is a number. Some of them actually start at 1, but I'm just letting you know, obviously. Any questions or doubts? So As we can see here, motherboards can come in many different configurations and models and sizes. Even the ATX board that we saw in one slide had different ports compared to the next ATX. What skill can we use, behavioral skill, to be able to deal with the change in the approach for each one? It's going to be constant change. What behavioral skill deals with constant change? We need to constantly change. So from
Adaptability.
that is correct. Adaptability, being able to adapt is going to help. Also, growth mindset's going to help us, right? Because the more we repeat the use and learning of this motherboard, the more we're going to be able to obviously use those neurons or pathways that we have set in to be able to do. But obviously, as Teresa alluded to there, adaptability is one of the ones that we're going to have to use because we're going to have to adapt to every given situation. Thank you. What will you do if you're asked to take responsibility for a motherboard you are unfamiliar with? Christina, what will you do?
I would look up the manufacturer of the motherboard.
Yeah, good, good. That's one, right? Pablo, what else can I do if let's say I can't find that manufacturer's information, their proprietary information somehow doesn't have it there because maybe you work for I don't know, Amazon or FedEx, and it's some special little motherboard that you're unfamiliar with. Who can I reach out then to? So it's not in the website of Packard Bell or whoever it is. Who can I reach out to, or what can I do?
I guess just consult your team.
Right. Definitely consult with your team, because most likely somewhere within the company there's got to be some type of documentation, although it's not publicly made. And most likely, if it is a Fortune 500, as we said, there's some type of documentation. Your supervisor and or co-workers will have that information in references to the special motherboard if necessary. Christina and Pablo. Next, if we can have Carlos. No, Carlos is out, right? Is Carlos here? Oh, he was. That's right. He had a personal matter, unfortunately.
He's out.
He can't make it today. Ilejane, if you can help us with this slide, please. This is basically there are several motherboard maintenance checks. You can just review those for us and read them out. Eve?
Okay. Clean expansion cards and motherboard biannually. Keep the PC free of dust, compressed air, or mini PC vacuum. Chip creep check. Over time, many chips may become dislodged due to thermal expansion and contraction. Connectivity check. Perform an annual check to confirm that all components and cables are connected correctly.
Yeah, thank you. So the motherboard itself, due to the location that it may be, I'm pretty sure you guys have seen it. You started seeing dust collect at the end of where all the fan is and stuff like that. So imagine if your fan on the outside has this dust, you could only imagine how much dust has collected inside the actual unit. There is always a special type of compressed air for computers and a mini vacuum. So we need to also be careful, as we stated before, these chips are very, very sensitive. So when we're going in there, we want to make sure it's not your house vacuum, because if you suck onto this chip with your, I'm pretty sure some of you, I know back in the day, people used to put it to their face and play around with it. You can see it sucks real well, the one that's at home. You don't want to put that one with the special nose and start cleaning in there, because that's going to suck so hard that it will bend the chip. Also, hopefully we have obviously turned it off, grounded ourselves properly, or have some type of protective ESD equipment with us, right? So be very careful whenever we're going in there and cleaning this. This should be obviously done hopefully biannually. Some of them happen as they come in. So as soon as you get the actual computer for repairs, some companies have what they call just like preventive maintenance, lack of any other better name, where when it comes in, then, you know, if you see that it's obviously dusty and stuff, you should clean it out yourself. Make sure you do the maintenance to the unit, because most of the times this doesn't happen. They're not dispatching technicians out there just to go and clean. We're not. That doesn't happen. Obviously, it should, but I'd imagine, and most of the times, what they do is by attrition. So as soon attrition means as they come in, they do them. Any questions in this slide? So what they mean by thermal expansion, so because of the heat, things will expand, just like maybe you also notice with your door, if it's raining or something, sometimes it's hard to open the door all of a sudden due to the actual expansion of the chip. It'll probably move and dislodge, and creating slow or sporadic breakdown on the actual PC. So another thing that they ask you when you're doing this type of checks on a PC, so you're going to upgrade maybe the memory or whatever, that you check everything. This is part of the normal maintenance check that you would do if you were doing it. Step one. DeAndre.
Am I clear?
Yeah.
Okay. Step one, research the type of motherboard. Before replacing a motherboard, be sure that it is the cause of the problem. Sometimes it is better to buy a new PC than replace a mobile. Researching the type of motherboard includes reading the documentation, verifying the form factor, checking the CPU socket, chipset and power supply requirements, number of bus slots and other connectors, slots and ports. Determine costs over features and buying from a reputable dealer.
Thank you. So yeah, basically what they're trying to say is if you're going to go and replace this motherboard, sometimes just going and buying another computer will be most likely, especially nowadays, much cheaper than you going and purchasing another motherboard to replace it. One, a lot of times this motherboard is already old and antiquated. As we all know, the new iPhone comes out every year, and watch it. If they could, they'd probably push them out even faster. And or any other computer. As soon as 1 year comes and the other one, it's already so old when it comes to computer terms that it's not even worth it. It's going to cost you as much as one of these brand new computers, and then you might as well just buy the brand new computer and transfer the data instead of wasting your money on that. Obviously, not everybody has that type of money, because sometimes the motherboard is slightly less than a computer, but it just doesn't make sense. At times they don't even have the parts available. Any questions or doubts on why you would have to verify the form factor? As we notice, ATX, mini ATX, nano ATX, those are the form factors that they're talking about. The same thing with the amount of slots and the type of PCI slot that you have, right? Because it could be PCIe, PCI. You want to make sure that you have the exact same. An ATX board has different layouts. We want to make sure all ATX boards that we're dealing with is going to be the one that we need. Thank you, DeAndre. Jose, that was it again. I hate this. Alexa.
Step 2, install motherboard. Steps to install motherboard are: confirm the right board has been selected, remove components, then remove the old board. Install the I/O metal plate, mount the board in the case, install conductors, install RAM, attach all components, attach cables, install flashing cards, attach monitor, keyboard, mouse using the I/O interface.
Thank you. So, as you can see here, they're speaking in reference to something that's obviously with nothing inside at this point. That's what you're doing. You're installing the motherboard, and you're going to be removing all the components before you bring in the new one. Any questions in the steps itself? It's pretty self-explanatory. This is, I believe, what we should kind of know already from what we've seen from the other presentation from last week of taking out everything, right? There should be a certain order and putting things dumpty back again, right? Any questions on the components, maybe something that they've mentioned here? Okay. Thank you, Alexa. Daniel, step 3.
Verify BIOS setup by booting system and pressing the function button listed during the initial splash screen. Check time/date, disable abbreviated post, set boot order, ensure SATA is enabled if HDD is SATA, save configuration and exit, observe posts, verify no errors are present, observe windows, verify no error are present, install motherboard, expansion cards, and other devices as needed, and reboot system as needed to make adjustments in OS or BIOS.
Okay. Thank you. Kind of weird what they say there, but obviously install motherboard, expansion cards, and other drivers as needed. They're just saying that the actual drivers for the motherboard, not that you're going to be installing at that point the motherboard, because obviously, hopefully all that stuff is in there. In case if there was a confusion on that sentence, at least I was, the first time I ever read it, I was like, what? How am I going to install the motherboard? It should be already installed, right? If I'm in the BIOS. But what they're just talking about is the OS. So when you come up with the operating system, if anything is not inside the OS, you're going to get what they call the simple drivers or generic drivers. And so it's not going to be working as actual it's supposed to be. So sometimes you need to download the drivers from the manufacturer of the expansion cards and or motherboard or other devices inside this computer to be able to get up and running. In most cases, though, if you're installing or replacing the actual motherboard that was in place, then basically the OS should not even notice anything. He can care less what the serial number is. Everything to the operating system would stay the same if you put exact same motherboard and everything back in the same exact slot. Questions, doubts? Thank you, Daniel. So, common pitfalls when installing motherboards. Always, always, always remember your ESD is your friend. Be that you're using a bracelet or a mat as would be the best bet, or the gloves, right? Never wear jewelry. So if I would go and want to touch a computer, I should be taking off my ring. I should be taking off my watch. I should take off my necklace. You at that point should be almost like a doctor. Obviously, you're not going to have the actual gloves of a doctor, but you might have ESD gloves on to ensure that you do not create any ESD inside the actual device, electric static discharge. Always hold on the edges, not on the actual copper or metal, any of the parts of the metal that's on these devices. You want to make sure you hold it on the actual edge. Avoid magnets. Please keep speakers. That's one fall. Sometimes I've seen technicians, they might have a speaker on their IT, and then they'll put the hard drive or a memory chip on top of that speaker. You got to be careful on what's around your surroundings. Don't believe that you could actually microwave a hard drive or a iPad to be able to dry it. That is not true. That's another common pitfall. You'd be surprised what people try to put out there. Take care of the screws. Make sure you do not force these screws in a weird way, because they're very, very picky, and then you'll mess it up. It won't go in. The same thing, if you tighten it too much, you might break something. So you shouldn't be tightening these things with a power drill or anything like that. It should be to touch. Never force to fit anything. All input, output, whether it be expansion cards, whatever it is, it should easily go in with no problems. Lázaro, what is the difference between installing and configuring a motherboard? It's a big difference. Installing and then just configuring a motherboard.
Installing just means actually putting the device and connecting the devices to the motherboard, and configuration is making sure those devices are actually communicating correctly to the motherboard and etc.
Mhm. So in configuring, I am actually going into the BIOS and making sure everything is correct and set up good, while installing is just basically that, physically screwing all the components, putting everything in. Thank you. Yes. When would you need to configure a motherboard, DeAndre? When would you need to configure a motherboard?
You said when would you need to configure a motherboard?
Yeah. So we learned that the difference between installing and configuring is installing is the physical nature of it, putting all the screws and Humpty Dumpty back again, while configuring is going into the BIOS and doing changes so that it recognizes certain things. So when will I need to go into the BIOS itself to the motherboard?
Would you like to have to do that like after you added new components?
Correct. Thank you. Is exactly what I was looking for. Whenever you're doing any type of physical change to the computer, so if I put a brand new video card or some type of memories or something, I want to go in there, make sure everything's being recognized. Sometimes even the computers nowadays even tell you hit F1 to save, make sure, hey, look, I noticed there's a new graphics card, or I noticed there's more memory. You want me to save this? But at the same time, we should always go in there if we're putting new drives, if we want to change the order, or make sure that everything's being recognized correctly. We should be going in there whenever we put in one. Thank you very much, DeAndre. That's correct. Mohammed, how will you know it's time to perform maintenance on a motherboard? So how would I know? What's one key thing that I probably notice physically with it?
Physically, uh, when there's an error or maybe you need to update.
Yeah. Maybe it's starting to heat up,
Something.
it's not spinning fast enough, right?
Okay.
And usually they tell us that we should do it biannually. Even if we haven't had any issue, we should biannually obviously do the performance maintenance. That's for your personal computers and at work. But we learned that most of these Fortune 500 or big companies, usually what they do is by attrition. So as the computer comes in for repairs, then they actually do that, because doing that to 500,000 computers worldwide every 6 months is not going to happen. It's just the logistics of it is just too painstaking. They have, though, what they call PC life cycle, which is basically the life cycle of a PC is usually 5 years. So then they will replace your PC without you having to purchase or to justify for a new computer. That they do. Behavioral skills and mindsets. Let's look here in Teresa. What do you think will be the hardest part about mastering skills related with motherboards? What will be the hardest one there? Out of all my behavioral skills and mindset, what's going to be the hardest one?
I think adapting, because there's always a new model, so you'll have to constantly know.
You hit it right there. It's gonna, unfortunately, you're gonna have to adapt and continue to have both adaptability and growth mindset. You have to be persistent also, because it's gonna take persistence and determination from your part, that every year when they come up with the latest and greatest, that you continue to learn these things. Unless if you become the CEO of some certain company, then you're gonna obviously give that to somebody else. But in the realm of technology and technicians and or your job, you will, like she just said, Teresa hit it right on that thing, adapt, need to be able to continue to learn and be persistent. Thank you. So using a BIOS to configure a motherboard. Complete questions. I guess we have questions here. Daniel, can you read this slide for us, please?
The common issues with the motherboard. Most common issues that call centers receive related to motherboard, but mostly related to the components. Electrical or burning smell. Computers don't boot. Beeps are hard instead. Cannot log in using BIOS password. buttons on front panel are not working, motherboard lights up but won't power on, and hardware not recognized by BIOS.
That one's a big pain in the butt. That was that part of that what we used to call the plug and pray. That one right there is a killer, because especially nowadays with this plug and pray technology, you are literally praying that it does recognize it, because if it doesn't want to recognize it and you double check that everything is connected right, it's one or two: either the slot's bad or the component's bad, or actually the third one is what I mentioned it earlier. The motherboard doesn't recognize it, right? So if it doesn't recognize it, it doesn't have it in the BIOS. The BIOS itself doesn't have the capabilities, or what you would consider the dictionary of that type of component, to be able to give it the instructions to do its job. Thank you, Daniel. Next slide here, Julie. How to solve common ones.
Fans are full of dust, causing motherboard to overheat, not enough power, incorrect components installed, RAM not seated correctly, components not inserted into the right port or slot, case buttons connected incorrectly, check hardware compatibility, shortened circuit and or broken capacitor equals replace board.
Thank you. Now you can see there's many different issues that a computer or motherboard in this case can give us. And if we could be part of the issue itself, not feeding in the RAM correctly, you'll hear that famous beep. A little Morse code was going to start happening, letting you know, depending on the motherboard, it has different beep sequences, right? And it will use that short, long beeps to let you know. Since it can't physically show it on the screen, it will beep, letting you know exactly what the post seems as a problem. Thank you, Julie. Okay. So now we have questions. If someone can read for us question number 1, so we can do it together. Here we are. Oh, no. Lázaro, number 1.
All right. CMOS settings can be set to factory default by C, resetting the CMOS battery on the motherboard.
That. Everybody agree? Mark it, bing it. Number 2, Justin.
Number 2 is, which of the following answers refers to a firmware interface designed as a replacement for BIOS? That would be A.
I'm sorry, for purpose of the team, what does A say, please?
UEFI.
EFI. UEFI. Thank you. Number 3, Jordan. Now I'm giving you guys hints here. If you look at the screen, if the answer is correct, it should be coming out green in my screen here. So if you guys want to, I think it allows you to go back and maybe check for those that you might think is not right. Number 3, Jordan.
Where do today's computers store almost all motherboard configuration data? A. BIOS ROM.
Okay. Everybody agree with that one? So
Oh.
Next one. No, some people don't.
For number 3?
Number 3, he put A. Everybody agree with him?
I thought it was.
It's not a problem, guys. We're gonna review it right after. Let's we'll confirm and make sure. Sometimes these tests that I'm sent in the presentation have the wrong answer, but we'll double check it now. Remember, this is
Diego. Where's this all at right now?
it should be in Nearpod. These questions, and you should be able to see these questions right now.
All right, so I guess everybody put A.
Not a problem. We'll look at it now. We'll read those now. Number 4, if somebody can help us read number 4. Alexa, there we go.
Which motherboard slot has direct access to the north bridge?
Mm-hmm. Which one do you guys?
I think it's either between D or A.
Okay.
But I think it's the primary one.
Everybody agree? Primary?
I agree.
Okay. Number 5, Christina.
Which variation of the PCI bus was specifically designed for laptops? C.
Yeah, I'm pretty sure it's C.
Mini PCI.
Okay. All right. All right, so let's look at the questions here. I wish I didn't say who exactly it was. All right. So we have here no, that's looks Alexa. It doesn't say the question. Does it say the question? I thought it said the question. From the looks of here, for being able to reset, that is a question, never mind. CMOS can be reset by default, and it says select all that apply.
I was right.
Questions where we need to be careful. And so it is, as we know, reseating, that's one. Choosing default option in the CMOS is another one. And there is a jumper within the motherboard next to the battery. There's also another way that I can hack into your computer without actually doing that. I can actually just turn it off. And then in that little jumper, we know those little gold teeth like we saw for the front panel. There's actually a little jumper that's there next to the battery with those 2 gold teeth. And then I can jump it. That means making sure that I short the circuit. I'm going to connect the 2 of them together. There's a little black or blue or whatever you want to call it, little jumper thing there that connects the 2 of them together, and it will reset your whole CMOS, not just the battery, not just the password per se, but everything. All of it will be set to default. So those are the 3 ways of doing it. The next question, we got that one right, which is the refers to the actual interface. We said the UEFI. The next one is actually the CMOS RAM. Remember that the BIOS ROM is read-only memory. So that would be my actual chip that has all of the BIOS information per se. But the guy that actually saves and uses a battery that saves the actual configuration, that's on the CMOS. That's why you have a CMOS battery, is to save on that RAM the information. That's why on number 1, I can clear my CMOS settings by taking out the battery. Questions? Doubts? Okay, number 4. Which motherboard slot has direct access to the North Bridge? Correct. That would be this guy here, because you notice the other one's kind of due to slower and or secondary components. Last is number 5. Which variation of PCI bus was specifically designed for laptops? And that one was the mini one, as we saw earlier in one of the slides. Real good. That's pretty much the session 4.